The sharp clack, clack, clack of metal keys striking paper echoed through the bustling newsroom of the New York Times in 1923. Dozens of journalists hunched over their Underwood typewriters, fingers flying across the keys with practiced precision, each keystroke permanently embedding ink onto paper. The air was thick with cigarette smoke and the metallic percussion of 100 typing machines working in unison, creating a symphony of productivity that defined an era. These men and women were masters of their craft, but they had no idea that the very tools beneath their fingertips represented just the first chapter in a story that would transform human civilization in ways they could never imagine. Fast forward exactly 100 years to 2023 and watch a 3-year-old child sitting in a restaurant, effortlessly swiping through videos on an iPad, their tiny fingers gliding across the glass surface with intuitive ease. No instruction manual needed, no training required. The child simply touches, swipes, and taps, interacting with technology as naturally as breathing. Between these two moments, between the thunderous mechanical typewriter and the silent, responsive touchscreen, lies one of the most fascinating and revolutionary journeys in technological history. This is the story of how we learned to talk to machines and how machines learned to listen. The tale begins not in the 20th century, but much earlier, in the minds of inventors who dreamed of mechanizing the written word. For thousands of years, humans had only one way to record their thoughts: by hand. Whether scratching symbols into clay tablets in ancient Mesopotamia or carefully inking manuscripts in medieval monasteries, writing was an intimate, time-consuming act that connected hand, eye, and mind. But by the early 1700s, as the printing press had already revolutionized the distribution of the written word, inventors began wondering, could a machine help create those words in the first place? The first patent for a typing machine was granted in 1714 to Henry Mill, an English engineer, though no working model survives and historians debate whether it was ever actually built. What we do know is that Mill's vision sparked something in the collective imagination. Throughout the 1800s, dozens of inventors across Europe and America tinkered away in workshops, each trying to solve the fundamental problem. How do you translate the movement of human fingers into mechanical action that produces letters on paper? The breakthrough came in 1868 when Christopher Latham Sholes, a newspaper editor and politician from Wisconsin, along with his colleagues Carlos Glidden and Samuel W. Sewell, developed what would become the first commercially successful typewriter. But calling it a breakthrough doesn't quite capture the messy, frustrating reality of innovation. Sholes' early prototypes were clumsy, unreliable machines that jammed constantly. The keys were arranged alphabetically, which seemed logical at first, but this layout created a catastrophic problem. Commonly used letter pairs were positioned close together, and when a fast typist struck these keys in quick succession, the metal type bars would collide mid-air and jam. This technical limitation led to one of the most consequential design decisions in the history of human-computer interaction. Sholes and his team rearranged the keyboard, deliberately separating frequently used letter combinations to prevent jamming. The result was the QWERTY layout, named for the first 6 letters in the top letter row. It was a compromise, a workaround, a solution born from mechanical constraint rather than optimal design. And yet, more than 150 years later, we still use it. Your smartphone keyboard, your laptop, the keyboard I'm describing this story on, all of them use QWERTY, a layout designed to slow typists down to prevent mechanical jams in a machine that no longer exists. This is the first of many paradoxes in our story: how limitations become legacies, how temporary solutions become permanent features, and how the ghosts of old technologies haunt the devices we use today. In 1873, Sholes sold his patent to the Remington Arms Company, the firearms manufacturer looking to diversify after the Civil War. The Remington Model 1, released in 1874, was the first typewriter to be mass-produced and marketed. It was an imposing machine, all black enamel and gold striping, with a distinctive feature: it typed only in capital letters. The lowercase letters wouldn't arrive until the Remington Model 2 in 1878. These early typewriters were expensive, costing about $125, equivalent to several months' salary for most workers. and were primarily purchased by businesses and professional offices. The typewriter's arrival triggered a profound social transformation that its inventors never anticipated. Before the typewriter, clerical work was almost exclusively male. The few women who worked in offices were rare exceptions, often relatives of the business owner. But the typewriter changed everything. As demand for typing services exploded in the 1880s and 1890s, a new job category emerged, the typist. And this job, for reasons both economic and social, became predominantly female. Women were paid less than men, making them attractive hires for businesses looking to cut costs. But there was also a perception, incorrect but powerful, that women's supposedly more nimble fingers made them naturally suited for the delicate work of typing. By 1900, typewriting schools had sprung up across America and Europe, training thousands of young women in the art of touch typing. These typewriter girls, as they were called, became the first large wave of women entering office work, fundamentally reshaping both the workplace and society's understanding of women's roles. The typewriter, a machine designed simply to mechanize writing, had accidentally become an engine of social change. Women gained economic independence, access to professional environments, and a foothold in the business world that would eventually open doors to broader opportunities, all because of a machine with metal keys and type bars.
But the typewriter did more than change who worked in offices. It changed how we think about writing itself. Before the typewriter, writing was personal. You could recognize someone's handwriting, see their personality in their loops and flourishes, observe their mood from the pressure of the pen. The typewriter standardized all of this away. Every letter was identical, uniform, impersonal. Some writers embraced this. Mark Twain, always an early adopter of technology, became one of the first authors to submit a typewritten manuscript to a publisher in 1883, Life on the Mississippi. Others resisted. Friedrich Nietzsche briefly used a typewriter when his failing eyesight made handwriting difficult, but he noted that the machine seemed to influence his writing style, making it more telegraphic, more staccato. Our writing equipment takes part in the forming of our thoughts, he wrote, an observation that would prove prophetic. As the 20th century dawned, the typewriter entered its golden age. Manufacturers competed fiercely, each trying to create the perfect machine. The result was an explosion of innovation. Portable typewriters appeared in the 1910s, allowing writers to take their work anywhere. Electric typewriters emerged in the 1920s, though they wouldn't become common until after World War II. Specialized keyboards were developed for different languages, mathematical notation, and even musical composition. By the 1950s, the typewriter had become so ubiquitous that the sound of typing was synonymous with productivity itself. But beneath this success, the seeds of the typewriter's obsolescence were already germinating. The problem wasn't the typewriter itself, it was what came after you typed. Once words were on paper, they were fixed, permanent. Want to rearrange paragraphs? Retype the entire page. Need to correct a spelling error? Use correction fluid or retype. Want to send your document to someone else? Type it again or make a carbon copy. The typewriter was a magnificent input device, but it was connected to nothing. Each keystroke was final, immutable, dead end. The solution to this problem would require a revolution in thinking about what input devices actually do. And that revolution was already underway in places far removed from the offices of typists and secretaries. During World War II, as complex military systems required new ways for humans to interact with machines, engineers began experimenting with alternative input methods. The bomb sight, the radar display, the early computers used for calculating artillery trajectories, all of these required interfaces more sophisticated than the simple typewriter keyboard. It was in this context that Douglas Engelbart, a young electrical engineering student, began formulating ideas that would reshape the world. After serving as a radar technician in the Navy during World War II, Engelbart became obsessed with the question: how could technology be used to augment human intelligence? Not replace it, not automate it, but amplify it, make it more powerful. In 1962, he published a paper titled Augmenting Human Intellect, a Conceptual Framework, which laid out a vision of humans and computers working together in ways that made both more capable.
Engelbart understood something fundamental.
The typewriter model of input, where every keystroke produced an immediate, permanent output, was wrong for the coming age of computing. Computers could store information, manipulate it, display it in different ways. But to unlock this potential, humans needed new ways to communicate with these machines. You couldn't just bolt a typewriter onto a computer and call it a day. You needed input devices that were as flexible, as dynamic, as multifaceted as the computers themselves. In his lab at Stanford Research Institute in the 1960s, Engelbart and his team began inventing the future. They developed the concept of windows on a screen, allowing multiple documents to be visible simultaneously. They created hypertext, where clicking on one word could jump you to related information elsewhere. They pioneered video conferencing, collaborative editing, and the idea that computers could be used for communication, not just calculation. But to make all of this work, they needed a way for users to point at things on the screen, to select, to move, to interact. The keyboard alone wasn't enough. The solution was the computer mouse. Engelbart and his colleague Bill English built the first prototype in 1964, a small wooden block with 2 metal wheels and a single button. It was crude, clunky, and revolutionary. The mouse translated the natural human gesture of pointing into something a computer could understand. Move your hand, and the cursor on screen moves correspondingly. Click the button, and you've selected something, issued a command, made a choice. It was intuitive in a way that keyboard commands could never be. On December 9, 1968, Engelbart gave what would later be called the mother of all demos at the Fall Joint Computer Conference in San Francisco. For 90 minutes, he demonstrated technologies that wouldn't become mainstream for decades: the mouse, Windows, hypertext, video conferencing, collaborative real-time editing. The audience of about 1,000 computer professionals sat in stunned silence, watching Engelbart navigate through documents with his mouse, clicking on hyperlinks, editing text that instantly updated on screen. It was like watching someone from the future. But the future took time to arrive. The mouse was too expensive, too unfamiliar, too different from what people were used to. Most computer users in the 1970s interacted with machines through keyboards alone, typing commands in arcane programming languages. The idea that you could point and click seemed frivolous, unnecessary, maybe even childish. Real computer users, the experts insisted, used keyboards and command lines. Pointing devices were toys. This attitude persisted even as researchers at Xerox's Palo Alto Research Institute, PARC, in the 1970s, refined Engelbart's ideas throughout the 1970s. The Xerox Alto, developed in 1973, was the first computer designed around a graphical user interface, or GUI. It had windows, icons, menus, and a mouse. It made computing visual, spatial, intuitive. But Xerox, incredibly, failed to commercialize this revolution. They had invented the future and then left it sitting in their research lab.
Enter Steve Jobs. In 1979, Jobs and a team from Apple visited Xerox PARC and saw the Alto. Jobs immediately understood what Xerox's management apparently didn't. This was the future of computing, not for specialists and programmers, but for everyone. Within minutes of seeing the Alto's interface, Jobs was shouting about its potential, imagining how it could be refined, improved, and brought to market. "Why aren't you doing anything with this?" he reportedly demanded. "This is the greatest thing. This is revolutionary." Apple's engineers spent the next several years refining the concepts they'd seen at PARC. The result was the Macintosh, released in January 1984 with a famous Super Bowl commercial directed by Ridley Scott. The Mac made the mouse mainstream. It had only one button, simpler than most other mice at the time, and it was designed to be approachable, friendly, non-threatening. You didn't need to memorize commands, you just pointed at what you wanted and clicked. It was computing for the rest of us, as Apple's marketing proclaimed. But even as the mouse was transforming desktop computing, a parallel revolution was unfolding in an unexpected place: the humble telephone.
Throughout the 1970s and 80s, researchers had been experimenting with touch-sensitive screens. The concept was simple. What if, instead of pointing at the screen with a mouse, you could just touch the screen directly? It would be more intuitive, more natural, eliminating the intermediary device entirely. The technology for touchscreens had actually existed since the 1960s. E.A. Johnson, a researcher at the Royal Raider establishment in England, published the first description of a capacitive touchscreen in 1965. Sam Hurst developed the first resistive touchscreen, which he called the elograph, in 1971. But these early touchscreens were expensive, imprecise, and fragile. They found niche applications, factory control panels, medical devices, high-end retail, but remained curiosities rather than mainstream technologies. The problem was that touchscreens of this era required precision. You touched specific spots, pressed specific buttons. They weren't forgiving, weren't flexible. They replaced physical buttons with virtual ones, but didn't reimagine what interaction could be. It would take another revolution in thinking to unlock their potential, and that revolution would come from understanding a simple truth. Fingers are not mice. A mouse is a precise pointing device. You can position a cursor at an exact pixel, click on a tiny icon, execute commands with surgical accuracy. Fingers, by contrast, are big, imprecise, blunt instruments. A fingertip covers dozens of pixels. You can't click on small buttons reliably with a finger. Early touchscreen interfaces tried to force fingers to behave like mice, and the result was frustrating, error-prone, and ultimately unsuccessful. The insight that changed everything was this. Instead of making touchscreens work like mice, make them work like touch. Allow multiple simultaneous touch points. Support gestures, swiping, pinching, spreading. Make the interface respond not just to where you touch, but how you touch. Make it dynamic, responsive, alive. This philosophy would come to define the next great revolution in input technology, but it would take decades to fully realize.